Hi guys, thank you for joining. My name is Marcos Arancibia. This is a special office hours for a hands-on lab for Oracle Machine Learning for Python on Autonomous Database. So together today with me we have Mark Hornick and Charla Monica, and they're going to be supporting you guys. So if you guys have any questions, and we're going to go through that process, but you're going to be using the Q&A, okay? So basically, I'm going to go quickly through the team. They're going to be helping you. Objectives, we're going to talk about the contents of the lab. And you're going to basically provision an autonomous database with me, and then we're going to start working on the labs, okay? So Marcos, Mark, and Sherry. So Mark is going to be monitoring Q&A. Sherry is going to be showing you guys and sending you guys some links in the chat, okay? So please be aware that that's going to be happening, so then you can go into the chat and keep it open so that you guys can click on the right links, right? So the objectives for the lab basically is make you guys understand and get a test drive on all the Oracle Machine Learning for Python capabilities, right? We're going to explore different aspects of the in-database machine learning algorithms. You're going to be able to see how we work with data, right? We pull data, push data, store data in specialized data store, and then work with AutoML, right? Now we are going to have some, do it yourself or try it yourself during the process, but definitely this is expected to be, well, this is a 120-minute, originally a 2-hour workshop. We're going to try to do it in an hour and a half, and that's going to get you guys familiar with it, right? And hopefully get you self-sufficient with the process. We're going to be focusing basically on the Python APIs today. We are working on a new live labs called the Oracle Machine Learning Fundamentals, right? That's going to show all these different components and new stuff. This one is specifically for the Python API. And we're not going to cover, basic machine learning 101. We have more of those. So if you're curious, you can go to the Ask Tom series and then take a look at the stuff that are from May 2020 onwards. We had some 101 on specific algorithms, right, and specific types of machine learning processes. So lab 0, basically we're going to provision an autonomous database, create the autonomous database users, and then from lab 1 on, we're going to be hands-on on the getting started with the notebooks, and then machine learning for Pi, all the processes, right? So we have from table creation, manipulation of data, machine learning algorithms, store and manage Python objects. And then we're going to run user-defined functions, right? And then we're going to use AutoML. If we have time enough, which I hope we do, we're going to get to the AutoML UI, right? And then you can always access this workshop, right? 365, 24/7, right? So if you can't follow us or if you fall behind, don't worry about it, right? Again, if you have questions or problems, right, technical problems running or getting access to it, talk to us in the Q&A, okay? So we're going to go and we're going to provision a free tier version of this autonomous database, right, on your own tenancy. If you have your own tenancy, you can run it on it. We suggest you to get an always free database, so I'm going to show you how to get that. So first things first, Sherry's going to post you guys this link for the workshop in the chat. Basically, you're going to go to bit.ly OML for Pi HOL, and that's going to get you to this page. So in this page, we're going to click either launch free trial workshop or run on your tenancy. Okay, so again, if you already have an autonomous database on your tenancy you want to use, great. If you have a tenancy, but you don't have an autonomous database running there, but you want to use your own, it's fine. So I'm going to show you how to create a always free autonomous database, right? Hopefully you guys already got that. And I would like to run a quick poll right now before we get started, which is, are you guys going to be following our instructions, or you just wanted to watch and look and see what's going on, right? So if you guys can answer that poll, it will be great.
Well, this is an interesting result. Yeah, we've got about 40% saying they're going to be actively doing it, and a good number that are interested in watching. So that should work out well.
That's excellent. So let's go and then start provisioning our autonomous database, right? So what happens now is you're going to click on that link, and this is what you're going to see, right? You're going to see there's a section here on the left-hand side, right? So hopefully you got to this page, and you can see that on the left-hand side, there's a lab 0, right? And also, if you guys are doing the green button, then this part does not apply to you because I'm going to be going through the autonomous database creation, and that's already done right on the green button side. All right, so lab 0, we're going to click on lab 0, and we're going to follow the instructions there, okay? So in another browser, right, or another tab, log into your Oracle Cloud instance. Now, that's what we're going to have to do. If you don't have an Oracle account, right, you're going to need an Oracle account. And actually, you even to get to the live labs, right, you're going to need an oracle.com account, right, to get in there. So the idea here is that if we want to create a new Oracle Cloud account, right, so then we're going to start one for free. You're going to need just to click on that link, again, the oracle.com/cloud/free. You can start for free, just fill in that information, say that you're a human, and then we should be good to go. Once you get that, right, once you signed in, you're going to get an email, right? And then you're going to be able to use that to log into the Oracle Cloud infrastructure, right? So once that email is received and you get that information, it should be soon, right? It should be fast. Then once you get into this link, you click on the link, and when you see this window on the left-hand side where it says single sign-on, just use the default that says there, Oracle Identity Cloud Service, and just click continue. And that's going to pop open a new window where you're going to be able to click and log in with your username and the password. Okay, so this is what you guys are going to have to see. Once you're able to log in into the Oracle Cloud, you're going to be able to see this screen. Okay, it might be a little bit different. You know, on the top right, you might be, because you're using a free tier, you might be going into one of the other data centers. But that's basically the idea, right? You're going to see something like this, right? So let me know. You know, let's run another poll, Sherry, where we're checking whether you guys were able to get to this screen, right?
And as we're waiting for that, we did have a few questions that came up as far as can we get the recording later? And yes, we'll be posting that to the Ask Tom session. And also there was a question about OML for Pi on 19C Enterprise Database. And that is something that is coming soon. So I'm recommending you stay tuned to the blogs.oracle.com/machine learning to look for an update. We are in the final stages of that. All right, so as far as the poll goes, were you able to log in? Yes, we've got about half the folks saying yes, they can see the screen. A few are still waiting, and of course the remainder are just watching. So that's a good outcome. Excellent.
Right, that's great. All right, so another poll that, you know, just about this little process, right? So Sherry, if you can send that out. Just to get you guys going, I just wanted to make sure that, you know, we're really making an effort to make everything very easy, right, and simple. It's like you got to put your name and that information and click a button and get it done, right? So just wanted to check what you guys were thinking.
I'd say we've got more than 2/3 saying it's easy and very easy, a few moderately confused, and very few saying they felt it was difficult. So if you did find it difficult, please let us know. If you want to put some comments in the chat to us or email us directly, we'd like to hear from you. Let us know what you're thinking.
Right, and if you still have problems, you know, by all means, please let us know in the Q&A, right? So Mark can help and Sherry can help you guys set up, right? To make sure that you guys can follow along. All right, so let's go. So if you guys are here, then the idea is we're gonna first create a compartment, okay? Just to keep things organized. It's not super complicated, but let's try to create a compartment. So we click on the hamburger menu on the top left. We're gonna click on Identity and Security, and then we're gonna click Compartments, okay? All of these instructions that I'm telling you guys and showing you on the screen are available in the lab itself, right? As I was mentioning before. So very simple. Basically, let's get that going with the compartments, okay? So the idea here is you're gonna create a compartment for our job, right? So give it a name and a description. It's at your discretion, whatever you want to do it. The parent compartment is going to be the root, right? It's going to have your own tenancy name here, right? So it's fine. At the root level, you want to create a compartment called Oracle Machine Learning. So, and that's fine. So at that point, create compartment, and you should be able to see that compartment over there, okay? Again, if you guys don't, as I was mentioning before, right? We have all of that in the instructions. So if you clicked on launch free trial workshop, right? And you click on lab 0 here on the left, right? As you can see here, right, that I have here, then you scroll down, right? And the idea is you can click on expand all tasks, right? And you keep scrolling down and you're going to see the information, right? So everything that I'm doing is over here. And if you haven't been able to get to that screen creating your account, click on getting started. That guy shows you how to get started, you know, exactly, right? How to create your free trial account and sign into your account, okay? Those are the steps that I was showing there, okay? All right, so create compartment then. Now we're gonna go to lab 0 task 2, right? To create an autonomous database, okay? So again, the steps are there. We're gonna click on the top left menu here and then click on autonomous database under featured, okay? Now, you might have different options here. These are the options for the free tier account, okay? So if you have, you know, a company account, a different tenancy, you might have more options and different things, right? But if you click on hamburger menu under featured, autonomous database is going to be there. Okay? So we're going to select that. And then remember to switch compartment here, right? Because otherwise you're going to create an autonomous database, you know, on the root compartment. It's not terrible, but it's just, again, a suggestion of putting things on folders, right? So in this compartment, select the compartment that you are you chose, right? OML. In this case, it was the name of mine. I don't bother about the workload type, right? But we're going to be using a data warehouse one. And then click on Create Autonomous Database. Okay. Now, when you do that, you're going to have a long list of things, right? The first things are going to be the name, display name, and database name. Okay. So display name can have spaces. The database name cannot. Okay. So database name, keep it simple, right? Don't put the, you know, weird underscores and stuff like that. You know, we try to keep it more on the simple side. So I called it OML Labs, and then on that you're going to choose basically the default. So you don't really have to touch it. Default is data warehouse. Default is shared infrastructure. Now let's check the always free. Okay, 19C here. Now, if you're not on the free tier, this is going to make sure that to tell you that this can only be done on your home region. Okay. Or if you are not on the free tier, it might tell you that the always free accounts are only available on a different region. So if that happens, if you have a problem checking the always free, then at least make sure that it's a 1 OCPU, and you can give it an auto scaling that can help you. But 1 OCPU should be fine for all tests today. Okay. So you keep scrolling down. You got to give the password for the admin. That's the only thing that you need to enter here. Oracle does not like us to tell people what passwords to use. So be creative. one password that I know it works is something like welcome 12345 6 or whatever. So be creative on your own things. You got to have a cap, one uppercase, lowercase, and you need to have numbers there. So make sure you put something simple that you'll remember, right? Or write it down somewhere on your notes. And then everything else is the default here. There's nothing, I'm not changing anything. And I click a button, create autonomous database. And now your autonomous database instance is going to be in the provisioning mode, okay? It's not going to take long. It's going to be quick, but it's going to be going into provisioning, okay? So again, everything I'm saying, it's in the instructions, right? So if you guys follow the instructions, you're going to see that there. So right now, I'm going to play a quick video on the Oracle Machine Learning for Pi, and then I'll continue from there.
So you have enterprise data managed by Oracle Autonomous Database, and you have data scientists who use Python. Data scientists need data. The database has data. What if we could bring these two great technologies together? What if data scientists could use familiar Pandas DataFrame functions to explore, prepare, and analyze database tables and views as though they were Pandas DataFrames transparently? What if data scientists could build machine learning models at scale directly in the database using those same familiar Pandas DataFrame proxy objects and a native Python API to in-database algorithms, and leverage automatic machine learning, AutoML, as a productivity tool? What if data scientists could couple this with additional Python packages like scikit-learn and matplotlib to develop and deploy solutions with user-defined functions stored in the database, and then, using REST endpoints, deployed easily using database-spawned and managed Python engines, where functions and data are automatically loaded, even with parallel options? Well, with Oracle Machine Learning for Python and Oracle Autonomous Database, data scientists can do just that. So what are you waiting for? Learn more at oracle.com/machine-learning and take OML for Pi for a free test drive in Oracle Autonomous Database.
Basically, what I'm going to give you guys is a quick introduction to Oracle Machine Learning for Pi, and then we're going to go and visit and check whether your instances are already running. They probably should be already, but so basically, the Oracle Machine Learning is a family of products, right? We have components for data science languages, right? SQL being very powerful and of course native to Oracle database, but then we have R, and then we have Python, right, as languages that evolved over the years into the capability of doing machine learning, right? So we have the OML Notebooks, which we're going to be using today. We have Oracle Data Miner, which has been just recently, a few weeks back, right, enabled to work with autonomous database as well. We have the Oracle Machine Learning for Spark that is part of the Big Data Service. And then we have the new components in the family, which is the AutoML UI and the Oracle Machine Learning Services, right? So basically, the idea is to try to facilitate, right, to try to make it easy for data scientists, right, to automate, scale, and deploy, right, their projects. So OML for Pi basically empower the scientists with all these capabilities, right? We have basically using the power of the database, the power and the capability of the database, right, the scalability to run our Python, workloads. We can run parallelized and distributed algorithms that we created already in the database from Python, right? So we created an interface to it. We can run basically whatever function you guys have, right? User-defined Python functions that we can spawn and execute and run in parallel using the database capabilities. And we have the AutoML and the model explainability capabilities. We're going to take a look later today. So we're going to go now to the Lab 0, task number 4, right, to access the database actions interface. And then before we do, quick poll again, Sherry, for the readiness. Hopefully, all of you guys that were trying to launch this we're able to get the ADW in green, right?
Okay.
So please let us know, and we can check if there's anyone that is not.
Looks like everybody's right on schedule there.
Right, and for the guys that are just a bit behind, just let us know, okay? And contact us in chat if you don't get this to this screen, okay? But again, at the same time, the instructions again are very clear. So all the steps that I'm doing are there, okay? All right, guys. So once you see this guy in green available, we launch the database actions, okay? This button now, it's different than the previous version. So this guy now should open directly into the administrator. So it's going to automatically log in with admin into the database actions for you, okay? In previous versions, we needed to enter admin and the password that you guys typed. So this guy should be very easy for you. So once you get in, this is how the database actions looks like, okay? And then the idea is that you should be able to click here on SQL on the top left here, okay? And that guy is going to be where we want to go. We want to go into that SQL, okay, worksheet. So when you go there, make sure that in the workshop, Lab 0 Task 5, there is some code that I put there, right? So if you go here on Lab 0, right, and you guys go to task number 5, there is code here. Okay, what I need you guys to do is to click on copy, right, to copy this code to the clipboard, and then we're going to paste it in the database actions, okay? So once you have that SQL, after you clicked on that SQL, right, to open that, you got to click on copy here, and now you're going to paste the code inside this area here, okay? So once the database actions SQL worksheet opens up, you're going to see this screen. You're going to paste that code here, and you're going to either press F5 or you're going to click on the button here to run the entire script. Okay? Make sure you click on this button here, right? The play button on the worksheet. Okay? So the idea is that process is going to create for you the Oracle Machine Learning user, right? That we're going to use on the demos. Okay. All right. So again, if you guys fall behind, make sure to keep looking at the instructions. All right. So we're going to go lab 1, getting started with OML for Pi. We wanted to get you guys a little bit of information from you again, another poll, to understand whether you guys are familiar with notebooks, right? Or which notebooks have you guys used, right?
And as we wait for the response for that, one of the questions we just had was, does Python run inside the database? Is there a Python VM like there is a JVM inside of the database? And the response is essentially that the Python engine is in a separate VM on the autonomous database environment. It's not actually running in the kernel of the database. And so this is really in contrast to what we do with the OML SQL interface, where the algorithms are run in the kernel of the database, and OML provides access to that. And Marcus is going to cover that in some detail as we go forward in the other labs.
Right. Perfect.
And familiarity here, we've got Zeppelin, 27%. Jupyter is the overwhelming winner with over 2/3. Jupyter Lab has got about a quarter, and some are doing something else, and a few are not familiar with notebooks.
Okay, excellent. That's great. All right, so thank you guys. So then the idea now here is we're going to go back to the ADW screen. Okay, we're done with the database actions for now. Okay, we're actually for this lab we're done with it. We're going to go back to our ADW screen, right? And then we're going to click on Service Console this time. Okay, so Service Console is going to open up in a different window or a tab. And I want you guys to go down to Development. And down here, you're going to see the Oracle Machine Learning user interface. Okay. So we're going to click on that. Once we're there, even though we didn't want to tell you the password, but this password was hard-coded in the code you guys copied and pasted, right? So now you're going to log in with the OML user, and the password is AABBCC123456. Okay. So Sherry, you want to share that password with the people in chat? Probably, I think it will be a good idea. Thank you. So make sure to use OML user and that password, okay? And then you're going to see the screen for the Oracle Machine Learning notebooks, okay? Or Oracle Machine Learning UI, actually, right? Where you have all of these options. And we're going to select notebooks, okay, from the screen. All right. Now, very, very important here, right? So we want to go to lab 1, and you guys are going to click on the click here to download zip file. Sherry can put that in the chat as well so that you guys can click that link. But basically, the idea is this guy downloads a zip file. So that zip file is going to contain all the notebooks we're going to use in JSON format, okay? So you're going to click on that, and then we're going to click on import, and you guys go, and wherever you guys unzip those files, you're going to import them, okay? So if you guys are here, then, right, lab 1, as I mentioned, we're going to go lab 1, right? And then you access here Service Console. This is how you access that. And then lab 1, task 2, you see there's a link here. If you click on that link, it's going to tell you, okay, I want to download this zip file locally, okay? And that's what Sherry also is sharing the link in the chat, okay? So once we are there, the idea is that this is what you guys are going to see, right? So I'm doing this with you guys. So there's nothing here, right? I'm in the notebooks. I'm going to click import. And then I see the files that I downloaded, right? So these are the files that I downloaded. And I unzipped, and I click open. And I'm going to see a list of the notebooks. And it's going to tell me, okay, these were the 7 out of 7 notebooks imported successfully. That's it. So now we are inside the notebooks, okay? How do they work? So if you click on lab 1, you can click on lab 1 to open it. And then the idea here is we want to make sure that the interpreter bindings are set, okay? That's critical. So every time you open a notebook, someone gave you one, you got one from our GitHub, you have to make sure that you can open it up and then set up the interpreter bindings, okay? So let's do that. So I'm going to click on lab 1. And then you get the lab 1 open. And remember, it's going to take some time, right? Because it's firing up the engines behind the scenes to run the Zeppelin-based notebook, right, on your behalf. So right here on the top right, there's a little gear called the interpreter binding. You got to click on it, right? And we want to make sure that one of these guys is selected, right? At least one. I like to use the medium. Makes things a little faster. So you drag and drop the medium to the top. You can turn off the others. It doesn't matter because Zeppelin only pays attention to the top one that can process, Python, for example, right? So whatever other guy can process Python is going to be secondary to this one. So I'm going to leave on medium, and then I click save, okay? You can use high as well, but it's just like if you have other people running together with you in that process, maybe more than 3 high processes might be too much already. for the system, right, for the entire environment. So we want to be smart, right, about our resources there. So run all paragraphs. Yep. Okay. So what I want to do here is run all paragraphs. Okay. Just so that if you run it, you can see that in the date down here, right, it says the current date and time. Okay. So I'm running everything now. And then I can see the commands, right? So basically the idea is for every notebook here, and let me show you the overview of this thing, right? So you have on top, you have things like run all, like we clicked, right? You can show and hide code, this at the entire notebook level, right? Clear output, clear notebook, that's very dangerous. Export notebook, right? So you can export that into a JSON format. We're working on, I think, the export to Jupyter as well, based on what Zeppelin allows us to do, right? And then search code. And then on the right-hand side here, we have a number of connected users. So because it's a shared environment, right? So if you and a buddy of yours are working together on a project, right? You can see how many people are watching this in real time. And then you can actually make changes in real time and collaboratively and see what the other is doing, okay? And then the list shortcuts, interpreter bindings that we were talking about. And then for every paragraph, you have specific things. The paragraph status, right? The run, so you want to run only that piece of code. And then show editor or hide output and things along those lines, right? And more features, right? You normally use for the width of the paragraph, right? Run all below, clone paragraph, show title, things along those lines, right? All right, so with that said, we are here in the, because we ran everything, right? This is just showing you a basic thing, help object. So showing you very basic Python commands, how to use the help. So the lab one is just a general, very simple one, just to show you how to use these things, right? So what we want to do is we want to go back to lab 1A. So we click on the hamburger menu, and now we go to notebooks, okay? So that means I'm going back to notebooks, and this is lab 1A. That's the lab that I'm coming in, okay? Lab 1A. So lab 1A, we're going to go into lab 1A, and then we click on the hamburger menu, notebooks, lab 1A, and we click on that. Okay, we're going to click on that lab. Now, that lab, we want to make sure that the interpreters are there, and we're going to run all paragraphs. The idea here is this lab is creating files and creating databases for us to use. And creating tables, right, out of files that are, in GitHub in this case, right, and things along those lines, right? So that's basically what we want to see. We want to run everything and go all the way to the end and see and make sure that this thing is showing you the current date. Okay. So I'm going to show again, as always, click on interpreter binding, make sure that everything is set. Maybe put medium to the top. So at least one has to be in blue, right? And I click on run all paragraphs, right? So you can see that the first step here is we are actually grabbing data from GitHub using the Oracle DBMS Cloud, right? So we're using Oracle DBMS Cloud create external table. So we are creating an external table into Autonomous Database directly from a CSV file that is in GitHub, okay? And then after we do that, we are creating local tables, right? We're creating a local table based on the external table, okay? Just to make it easy on us. All right, and then, if you scroll down the code, all we want to do is we want to make sure that, we're granting, access to views and things like that. We want to make sure that you see this, right? The date here shown on the bottom is the current date. Okay, that just means, okay, we ran everything, right? And everything is finished. All right. Okay, so we're going to go back to notebooks again. Okay, so now we're going to lab 2, select and manipulate data using a transparency layer. Okay, so I'm going to give you a quick fast track on what we're going to see, and then we're going to do it, right? So we're going to take a look at what transparency layer does. Transparency layer for us means you do something writing Python code, but behind the scenes, Oracle Machine Learning for Python is translating those things into actual SQL so that the database can use it, right? For example, I can do OML create, OML sync. OML create takes a local data frame and pushes it to the database and says, okay, this now is a table called Boston, right? OML sync says there is a table already in the database that I want to use as a transparent object in Python, right? And that's what we do. So it's a proxy object that we create for you. Or you have a query. That's fine. You do select star from whatever. It's a SQL query, and we're actually creating a proxy object for you. With that proxy object, you can do all those things on the right, for example, right? Shape, head, describe, standard deviation, skewness. You can split the data, right? So there's a lot of Pandas commands that you can use, right? Standard Pandas DataFrame commands. And so the way it works behind the scenes is exactly like this. You do a sync, so now this onTime_s proxy object in Python is a Pandas DataFrame for Python, but for Oracle, it's actually a proxy to a table, right? And because it's a Pandas DataFrame native object, right, or proxy object, then you do a cross tab on destination, right, on dest, on that column dest. So what we do is we take that information, we pass it to the Oracle database. The Oracle database sees a query, and it processes the query, and the output comes back to you as you would expect. As a Python user, I would expect the cross tab to give me this result, right? As a database user, I might be expecting that query to come. So that's basically the idea. As a Python user, I don't care about what the database is doing. I'm looking at my side as a Python user, and I am getting the results that I need, right? So this is what we're going to do in Lab 2, right? We're going to import the libraries. We're going to check how to select tables and proxy objects. We are going to be familiar with OML DataFrame proxy objects. We're going to do a splits and k-fold. We're going to do cross-tab and pivots. And then we're going to go into the graphics. And we're going to do a manipulation of that data, right, using the transparency layer. And finally, some CX Oracle functions as well, right? Which is the CX Oracle is the driver, the open source driver that Oracle provides to any Python components, right? To connect to the Oracle database. So let's take a look then there, okay? So Mark, Cherry, how are we going in terms of, are people okay so far? Any critical questions, problems?
I think a lot of things are getting cleared up, hopefully. We did have a few folks running into issues with their screen access, but I think that's making progress.
Excellent. Okay, guys, so again, notebooks, right? We're gonna go notebooks, lab 2, okay? So once you get in there, this is what you're gonna see, right? You're gonna see the entire title here. We're gonna actually go and review the notebook tasks and basically go step by step. Okay, so I'm gonna go step by step with you guys. Okay, so basically, so here we go. So I'm gonna go lab 2. Okay, and lab 2. Then, if we scroll all the way up, make sure, remember. You guys are going to have to do this, right? Click on the interpreter bindings on the top right, right? And then make sure that you guys have at least one of these guys in blue, right? And ideally put the medium on top, right? So you can drag it and drop it, or you can just turn off the others as well. And then we gotta save it, okay? So now we're gonna click on the run all. Okay, so before we go through it, it's a good idea to run all paragraphs. The output is already there, so if you don't want to or you don't feel like, you can scroll down. The output is going to be there. But just in case you guys want to explore something else, you're curious about something or a type of something, and you want to add a paragraph by yourself, if you run them all, you get all the objects, right? So if you type something and try to execute just that, you're not even going to be, connected, right, to the OML at that point. It's going to show you, because you need to run the import pandas and import OML and things like that, right? So scrolling down, basically the idea here is we need to import the OML libraries, okay, and pandas as well. Second step here is we are taking scikit-learn datasets. So we provide a few Python native packages, right, or Python third-party packages, if you will, available. Scikit-learn is one of them that we provide with the autonomous interfaces, right? We're working on getting people to install any package they like, but for now we have that list, right? A list of packages that we can provide. So you're gonna do import pandas as PD, and then we're gonna load the iris dataset, right? Very famous iris dataset for flowers. And then you're gonna see the X and Y here out of that dataset, right? So this is just taking in the output, input and output, the target that normally we use, which is the flower species, and then we're taking in the other numerical columns here, and then with a z.show, it's a special function in Zeppelin that we offer together with that can actually understand, even though this is an Oracle Machine Learning data frame, it's going to understand it as a as a standard data frame from Python, and it's going to show you the result here, right? So this is a nice output that you get, right? So the functions that you can use are down here listed, right? So we have something like this, right? So you can, this is the list of functions that are transparently available, right, to the user once you have that data set, right, that data frame. So for example, if you do shape, you get something like, I have 150 records and 5 columns, right? And if you do head, you get, a top 3 here, right? Show me the first 3 records. So you guys go ahead and scroll down and take a look at the functions, okay? The second section here talked about selecting tables. So I can do a table of customer insurance. I can do a head of the show. So you're showing only the top 5 records here for me, right? But then you can have a specific selections, right? So in Python, this is how you select, columns, right? So I'm selecting just the 2 columns here. So this is the way that you write a Pandas data frame code, right? You're treating that as a normal Pandas data frame, right? If you continue going down, you can see this is the way that you select the rows, right? Remember that Python, it starts in 0, right? So 0 is the index, right, of the first row. So a row 0 to 4 gives the top 5 rows, right? And then we can go keep going, right, guys, and looking at these kinds of options, right? Now, task 3 goes into the select inside. So what the usual people, what you normally do in SQL, right, is let me select, a certain people, the number of people that gets, mortgage less than that number, right? And I only want to see the 2 columns. So this is, again, a very easy way to show that. When you do this, again, think about it, right? Transparently, what we're doing is you're typing Python code here. We're translating that into SQL behind the scenes, right? So you're getting the results that you expect, okay?
Marcos, just a point on that, because a question came up is, why do we need CX Oracle if it's an in-database implementation, right? And I think what you just said, it speaks directly to that, is we're actually taking the syntax that's there and the functions behind the scenes are translating that to SQL for in-database execution. So we don't have to pull the data out of the database, which is a major performance and potentially scalability impact. You want to keep the database in the database as much as possible.
Right. Perfect. Thank you, Mark. Exactly. So then the idea that's basically the magic and the beauty of the transparency, right? Is that I'm not pulling data out of the database. Everything is being, the query is being executed there, but these objects, remember, they are proxy objects, right? So even the result out of this is not coming to Python. It's another proxy object to a view that is being executed and run for you under, in your name, right? But it's there. So also another detail, if you close everything here now, this object is no longer in existence, right? Because again, these are all temporary objects, right, that are being created for you. So all temporary views. So unless you actually say materialize, which is one of the options, and then now you have a new set or a new table, right, with that. But unless you do that, the objects are going to disappear at the end of your session, right? So, and this is basically what data scientists do all the time, right? We experiment, we try things, and then we keep going, and sometimes things do not work. We want to test something else, right? So, all right. So basically, so we're gonna get, scrolling down again, data frame proxy objects, append functions. This is showing you guys how to join tables, to to put tables on the side or side to side on one on top of the other, right? And then those are the demos that we have here, right? Replace function, right? So on the left-hand side, you have the replace, and then on the right-hand side, you have the original one, which said no and yes. We're replacing those for 0 or 1, right, for example. So there's a lot of these functions that are available, combining columns, right? Again, I'm going to start going faster here, let you guys scroll through it, because we need to, we need to keep going, right? The merge function is the join. So you're saying, I have table 1, I have table 2. They both have customer ID, and I want to merge. I want to join those tables, right? And then you get the output. This is basically the output, right? Coming from the right, coming from the left, right? So you get the column names. You can rename the columns afterwards. Those are kind of the things that you can do, right? So I'm going to keep going here. You can drop rows and drop columns very easily as well. And then basically, I'm going to drop, like, you can drop columns with nulls, right? Rows with nulls, for example, very easily. So that's basically telling you, how that process works, right? Drop NA, right? That in this case, right? If you have any NA, right? Any nulls, you can do that. So I'll keep scrolling, right? Keep going. Drop duplicates, right? That's sometimes very critical for machine learning, right? But you want to drop duplicates, so that's basically available there. And then using the split and k-fold. So we're going to use split for all the machine learning stuff that we're doing. You just say, what's the ratio? Okay, so 80% and the second split is 20%. So you want to get the splits, and then you're going to see what is the splits that you're doing, right? So you're splitting the data into random samples, right? That's basically the idea. And you can do stratification, so stratified samples, and then you can split using hash. You can split. So there's a lot of capabilities, right? And k-fold function as well, right? So task 6 is using the crosstab and pivot table. Again, showing crosstab very easily, and the pivoting of the tables as well. So how many counts for female and male, right? So what's the proportions here? So all of these things are very easy, again, because you can write them in Python, but we're processing that in the database, right, ourselves, and then getting back to you only the results, right? And then finally the charting. So box plots and histograms. So we created this function. This is a special function, graphics box plot, that we do with OML. So you give me the inputs, right, and then the options here, and you get the output, right? And you can make it very different as well. We have we can use different styles, because you can do something like this, right? Use the style Seaborn, and this looks a little better than the raw default matplotlib chart, right? Then manage and export transparency layer functions. So you can create a persistent table, right, using the OML create. So if I have a standard Pandas DataFrame, right, a Pandas DataFrame here, I can take that and push that to the database and give it a name, and now it's a physical table that I have available, right, for later, okay? And the CX Oracle functions, so basically OML for Pi gives you the cursor for that CX Oracle. So if you wanted to do something special, a specific query that you're looking, that you just want that component, then you can do that as well, right? So you can just run a normal SQL query against the database that I'm connected right now, so I can use that cursor and execute and fetch and then close that cursor, right? Just like that. All right, so hopefully that was useful, guys. The idea now is we're going to be moving on. We're going to move on to lab 3. Okay, so for lab 3, we're going to be looking into the machine learning algorithms. And these are the algorithms we have right now. We are working on increasing the list. Basically, the idea is to get the others one. We have a few others that are available only in SQL, right? So potentially over time, we're going to be on par with all the different languages, right? And some others available in R and things along those lines, right? So, so what we do basically is that, you know, if you have OML available there, you can do a sync on a table, and then you define the parameters, right? What are the settings for that algorithm? When you do that, say I want to use a support vector machine algorithm for anomaly detection. I want to use this specific kernel function and these settings, right? The settings that were defined before here. And then when you say build the algorithm, right, with the fit, that's when the database is going to say, okay, give me the proxy object, right, for the table or the data that you want to use. There's no Y, right, because it's an anomaly detection. If you're doing a classification, you're going to have a Y like a target, right? And then you're going to be viewing the object, right? So we're gonna see how that works. So we're going to import libraries. We're going to create a regression and a clustering example, and we're going to check partition models, okay, and a rank attribute importance. So to do that, we're going to go again to our notebooks, right? And then we're going to click on lab 3, okay? So again, as before, click on top here, hamburger menu, notebooks. We're going to go to the list of notebooks and click on the lab 3, okay? And Mark and Sherry, so far so good? Specific questions?
Yeah, I think we're doing well. There is one question about how do we tie in with OCI data science? Is there a natural bridge between OML and OCI data science? And as I commented that, you know, we'll be having a standalone client being released relatively soon, and that's going to be made available on the OCI data science platform. So you will be able to have this connectivity between the two environments fairly seamlessly from that standpoint. So stay tuned. We'll be making announcements in the near term.
Excellent. Thank you. All right, guys. So lab 3, use in-database algorithms and models, okay? So first things first, we got to import the libraries. Because we're going to plot some charts, we're going to use matplotlib, and we need a NumPy as well. So we're going to be importing the libraries here, okay? Now, working with regression using GLM, we're going to just connect to the table that we just imported from GitHub, okay? So we pulled that table from GitHub when we were doing the lab 1A, and then we stored that in the database. So we're going to sync that table. We're going to check it out. It's a table with information about, you know, credit balance, funds, and number of dependents and children. So a lot of supplementary information, demographic information, income, you know, profession, credit card limits, and things like that, right? And then there is one column here that we're going to be using for our target. Okay, so when we do that, we're going to say, okay, first things first, I'm going to split the test and train. So I'm using that split function, right? Ratio 60%, 40%. That means train is getting 60% of the data of the original table. The test is getting 40%, right? And then now the train X, we're going to drop these columns out of it, right? The lifetime value bin and the lifetime value. because we want to use that as a target. So we're going to use lifetime value as a target. Okay, and for the test X, it's fine. We can use everything, and then the Y we use only the lifetime value. Okay, so building the regression model, then this is basically what we're doing here. Okay, so if you scroll down the settings, we're using feature generation. We're using a feature selection option. Okay, and these again are just selections, right? Are just settings, right? That you can. If you don't put anything in the settings, it's fine. It's going to just use the defaults, right? And then it's always important to drop any model that we're building that has the same name before, right? There's a rename where you can actually version that model as well in a smart way. But we're just dropping it out to make sure that there's no model with the same name. And now we're saying, let's build that GLM object, right? So it's a regression, and I'm going to take those settings that are on top. I'm going to use train X and train Y is my target. This is the model name, and this is the case ID, right? There's a column there that I don't want to be using as an input. It's a case ID, right? It's customer ID. So this is the result. So basically, it comes out like this. So you see all the information about the model, right? All the settings that were used, computed settings, the global statistics, attributes, right, that were used, and the coefficients, and whether the coefficient was significant, right? You see the little stars here on the right showing you that significance. It can get a little crazy, right? Because you did feature generation. It said, okay, age to the square is important, and age to the elevated to 3 here is also important, and then age to the square multiplied by car ownership might be important. So you can get a little too crazy with when you do feature generation, right? So you got to go back and pay attention to this and work your way out. But there are things that might be significant, and you scroll all the way down, and you're going to see, here the information, right? These are significant to the 99.99, level here, and that this is 1%, 5%, right? Things along those lines. So, all right. So now that we built the model, we can check the details, right? The fit details. So that tells you, adjusted R square. So they're saying, okay, that model is amazing. All right, 98%, R square, right? Adjusted R square. That's probably too good to be true. But so did you get all that information about the quality of the model? You take a look at the coefficients, so you have the ability to just get the output from there, right? So the coefficients, so all of the things that we're showing in the table are available as things that you can query and store, right, and save. And then we're going to do prediction. So we're going to input the test data set here, and we're going to say, I don't want just only the predicted lifetime value. I want actually the original customer ID, so that I know, what the prediction belongs to, right? Who that prediction belongs to. And I want the original lifetime value so that I can compare myself. So that's something you can do, right? So you say predict, but give me these guys, right, as supplemental columns. So once you're looking at that, then you can just show the standard charts of the prediction versus the actual, right? So that's a usual target. You expect that to be a straight line if possible. The dots that are out here are showing me the errors, right? So the error was the lifetime value. Original was 19,000. The prediction was 24,000, right? So that's not a great prediction, right? But anyway, that's how this works. So, and if you want to do that in Python using matplotlib, you can, right? And this is the way to do it. So a very simple code here. We're using a diagonal line to show the ideal prediction. And we see that there are many people with some problems here, right? The original lifetime value was showing 0, right, to some customers here. Maybe there were nulls, right? So these are things that we need to investigate further, right? And then and I was trying to predict, and I was giving the customer some predictions, right, around those lines. And that shows up on the right-hand side where you see the lifetime value prediction versus the residuals, right? You expect this to be very randomly distributed, right? Randomly distributed here, but you see this line coming down, straight down here, which is the incorrect ones that we had. So, and then keep going, we have the basic, calculations that are important, right? So the R squared, now using the prediction versus the actuals, right? So using the test data set that we predicted, now we're using these this kind of score, right? The R squared and the root mean square error and things like that, right? So moving on to k-means to clustering, then it's going to be the same process, right? We're going to have some settings. We have some k-means. We're going to have we have to tell it how many clusters, right? We would like to compute. I think the default is 2, but you should make sure to tell it how many you would like, right? And then we're going to do a fit on that. And this is just a different style, right? A different style of calling the same processes that we called before, but it's the same thing, right? We're going to do a fit on that. So displaying the output of that k-means cluster, you see that whether it converged, right? The clusters that it generated, and the final leaf cluster count. So the 3 clusters that I requested are here, and these are the counts, right? And then you can have, I can see the details for those, right? For the clusters, I can see the taxonomy of that cluster, and I can, do the predict, which I wanted to do, right? So predict, give me the cluster, supplement a column. I'm going to give them all the columns, okay? So you can also do that. You can say, I would like to see the prediction plus give me everything else. So the output looks like this, right? You can see the cluster ID, right? Customer ID and everything else. So you can see customer X here, it belongs to cluster number 5. This guy belongs to cluster number 2, right? And so on and so forth. And so finally, we can show those predictions in a chart. So we can see what happened here, right? So lifetime value and income basically were the determined the clusters here, right? The specific ones. So you can see the line out there. Now, you can say, well, that doesn't really look like a good cluster, right? And those are the things that the data scientist is going to have to do, right? Because these guys look too similar, right? This group looks so similar. It's probably, you're going to take a look at this group versus some exceptions on the top or some exceptions down here, right? Those guys might be different. So different clustering techniques are available as well that would help you with that, okay? So finally, partition models. Basically what this is doing is we're going to do an SVM regression, but then we're going to say here, this special call, ODMS partition columns gender. What that does is that tells us, okay, I would like to build a machine learning algorithm or a machine learning model, but I want to build one per group. In this case, one per gender that is in the data set. So you're going to see now that we're going to tell you, okay, this is the model, right? But now look at the computed settings, right? So it's going to be one separated here per gender that I found on the data set, right? And you think about it, it's normally like one per zip code, one per region, right? You will always have different things, right? One per product type. So we're going to have basically what you end up with is 2 separate models. You end up with 2 models that are smart because now they're partitioned. So there's a smart enough so that when they see the new data coming in and it's time to score, I'll check gender and I'll say, okay, based on the gender, I'm going to use that model immediately, okay? So I have a completely separate model per gender. They can be using different, different inputs, everything, okay? So that's the idea. So if you think about it, I have to do 100 models for all my customers. If you do this partition model, you get one model that understands everyone else, right? So you have the customer ID there and you're splitting the models and then you're looking at all those, right? So that's basically it with the partition models. So very, very smart way to do this. And then as I mentioned before, you can materialize, right, that data set. One other thing that we have is called the prediction details. This is very important because I think most of the time when I was working in the industry, people would always ask me, hey Marcos, my call center person is about to call this person. What are the reasons why I should tell them, right? What are the reasons why I'm calling that person, right? So that's what we provide. We provide prediction details. That means every customer, and this is a SQL query that comes out of that and picks up these attributes, right? But every customer that I say this is the prediction, this is the reasons why. So I selected the top 3 reasons, right? The top 3 reasons is I gave this guy this prediction because he indicates he has no children, he has 1 mortgage, and he owns 1 home, right? This guy, though, on the other hand, I gave him this prediction because he has only 1 dependent, he has this income, and he have a specific number of online transactions, right? So, and I tell you the weights that were used to determine that, right? So this is very, very important and very magical when you're putting things in production and you're making sure that you can actually say what's the reason that prediction came out, right? All right. Moving on, we have the attribute importance using model explainability. That's also part of one of our models. So you do use the MLX component there. And basically what we're doing is we're saying, okay, I'm going to train a SVM model. But now after that is done, I want to use my global feature importance, right? The MLX is going to get me a global feature importance for a classification. I'm going to tell it what kind of score metric I'm using, and then run 4 parallel processes to come back with a result. So this is what it comes back with. This is looking at the model as if it was a black box, okay? Because it doesn't pay attention to the model. It's really like a global explainer, right? So it's looking at the model and then coming back with the global feature importance, telling me these are the attributes that are the most important as determined by your model that you're giving me, okay? So these are the things that the model are giving the most importance, right? And it's doing that by making a little change on the transactions and checking what's the output, right, of that prediction, what's the impact on that prediction, and then checking all of those things, okay? So basically that's the process. So you can get them in a Z-show format as well, right? In a nicer way. I rename the columns as well, so they look nice like that. Okay. All right, guys. So how are things coming, Mark, and questions? Any other
we've had a few more questions than that. I mean, some had to do with feature selection. If you want to use SHAP or Lime for local interpretation as opposed to that, and I think that goes back to the same comment we had earlier about third-party packages. That is something that when the standalone client is available, you'll be able to do that type of processing locally. And when later in the year, when we introduce the ability to install packages in the autonomous database environment, you'll be able to do that as well there. And on premises today, along with the database cloud service, you can install whatever you'd like there, as long as you have sort of a root and DBA privileges.
Right. Excellent. All right. So Lab 4 is about data store. So basically, this is how do you are typing Python, you're using Python locally, and then you're using Python with proxy objects. How do you store that for later, right? I might want to store all these things into a place where, next week when I come back, I don't have to recreate all of those objects, right? So we created a Python data store, right, where you can store all of these objects and preserve them, right, and load and write them. So, and we also have an OML for Py script repository where you can actually type your function and store that as a script. That's different than the data store. The data store could store functions as well, but you're not going to be able to use them right away as a function, right? On the script repository, it's smart because in addition to the SQL stuff that we're going to see today and to the Python capabilities, you can also use then a REST API to call in your Python function directly from your application, okay, another service. So we can talk about that. We have blogs about it as well. So let's take a quick look into this. There are a lot of tasks here. It's a very large Python lab. So I just want to make sure you guys have a quick look and then go through it. Okay. So again, notebooks, lab 4. All right. So I'll let you guys go through it because this is a long lab. It will have then several sections about how to exactly create these, store these pandas data frames. You see that, for example, right now, just to show you guys this, I'm not even running them all, right? Normally, you would ideally look at interpreter bindings and run them all before you start. But because I'm not making any changes, I don't need to. So I'm just scrolling down and seeing the results that were previously obtained back in September of last year in this case. So basically we're creating a few objects here. So we have some local objects and we're saving them to the to the data store, right? So you see we're using ds save. You can use ds dir to list, right, the directory of what is in the data store, right? So these are the objects that are stored in there, right? You can check the save the models models themselves directly into data store. So I can do a save the model. You see that I can give it a name, right? So that I know what is in my, I can give it a smarter name to know what the objects are in that store. So at that point, you have different data stores components, right? So I see a question was about whether we can save them as pickle, right? So actually, this is let's see, a replacement, right, for pickle, if you think about it, right? So we are doing what pickle does, but we're storing that in the database. I'm not sure if we can export them as pickle. That might be a good question, or a good enhancement, right, to pull the objects out and store them in the object storage, right, perhaps bucket as a pickle. I guess that could be something that we can explore. And then you can load data store objects, right, into memory. So you can just say, okay, load my data store, and it brings up all of your components right there, right? And then I see a question as well on the Q&A. You guys got to make sure that you run everything, right? You got to run all of the labs, the entire lab, before you can get to each of the paragraphs, right? If you try to run just one paragraph, it's going to fail. So again, the model comes back, so it's ready to use, right, in your environment. You can see data stores and other details as well. So you can see the user, which user created it. Manage data store privileges, so you can actually give people privileges, grant a data store to a different user. So it's a colleague of yours using the same project, you want to give them access to that data store. Okay, so as long as you both are on the same autonomous database instance, even if you're separate users, you can do that. And then delete data store content, and going down to task 10 are the script repository, right? So these are all the how do you type a script. So these are, you got to be careful with the quotes here, right? So these are triple double quotes, right? So you got to be careful if you close or open some of these guys inside, right? But that's basically the idea. And so you can run the code easily, and then you can create scripts in the repository, right? So we're storing those scripts in the repository, and then we're calling that function, right? So we're calling that, we're doing a script load, so that we're bringing that script into memory, right, to execute. All right, so that's basically it. You can do a dir to list all of the scripts that you have as well in the repository. And then store a function as a global function as well, and drop scripts from the repository, right? All right. So lab 5, we're going to use embedded Python execution. So we have special functions that what we do is we actually pass the name of that function we pass a function, we pass a data set to that function, and we tell, okay, I wrote this in Python, so I want my Python code to run with the packages that we allow you to, right, in Autonomous Database for now. But then the code is just plain Python, right? So what we're saying is you need to get an injection of Pandas DataFrame that is running inside that memory because whatever reason, right? Some of the functions do not work with Oracle database, or we don't have that available for the transparency layer. So you want to run those functions that you wrote yourself, and we're passing that information, right? So we're going to see examples of basically you can build something like this, right? I'm using scikit-learn to build a linear model. I'm building a linear regression using scikit-learn's linear regression. I'm not even doing anything with Oracle Machine Learning internal components here. And so you type that in the exact way that you would do in Python. And then you get access to a data frame. And then when you do group apply, for example, you're pushing the iris data frame. So that's a proxy object. Now we're passing an index, right? So that index is now saying, okay, I want to run this Python code, but I want to run it in parallel for every group or every index that I have. So what the database is going to do is the database is going to span separate threads and run Python engines in parallel. And each of them is going to take one of the different species, right? Because that's what you put as an index. And we're going to go through this. So now I'm building separate linear regression open source models, right? So from scikit-learn. But I'm using the Oracle database as this smart thing that is taking the data and parallelizing the items, right? So lab 5. Okay, so lab 5, we're going to go to Notebooks lab 5. Okay. And then I realize we're almost at the end of the time that we scheduled. So I'm going to stop in the middle here to go and ask you guys a few of the things that that can get you guys cleared. Okay. So actually, let me do that right now, right, Mark? So I'll do a real quick go back to the slides just to ask a couple of questions
Sounds good.
From the people. Okay. So what I'm going to do is, Sherry, if you want to share with the folks the last poll here, just to checking whether you think you guys got it, you understood what we were showing you so far, or you feel that's not really easy, or you guys need more time. I think that's going to be interesting for us to understand what you guys your level of understanding is right after this.
Yeah. I think we're seeing about half saying they're moderately comfortable, a few in the definitely category, and others, they need some more time and more experience with the technology. So that's good to see.
Okay, that's excellent. Thank you, guys. So so what I'm going to do is I'm going to just show you guys a few slides on where to get more information. Okay, and then I'm going to continue with lab 5 and 6. Which is probably going to be more, 10 more minutes. Okay. And then, so Solutions Showcase, Live Lab is available 24/7. We got a lot of interesting resources. I think Sherry might put that in chat, some of these links, right, for you guys. So we have examples of these notebooks in GitHub, and we actually have many, many more notebooks in GitHub available. We have machine learning live labs as well. So not only this one, but we have others available there. And we have office hours as well, right? So the sessions that you guys can come and we talk about the technology, right? And then once you guys are done, if you are done with your free tier account, you guys can sign out of the machine learning, and then probably you can stop your autonomous database. It's going to be there. You're going to get an email saying, this instance is going to be automatically, I think, shut down in probably 7 days if you don't use it, right? Or they have a limit, right? But if it's good to be a good citizen, if you guys are not using it, you can stop it, and then you can restart it, and it starts up very fast, right? When it comes time to use it. So I'd like to thank you guys for joining. What I'm going to do now is I'm going to continue with lab 5 and 6 just to make sure that we can finish this. But I did not want to hold you if you guys had any other meetings coming up, right? So, okay. So let me go back to lab 5. So I'm going to finish up this section and then make sure that if you guys have time and you're continuing with us, that you guys are getting the most out of it, right? So embedded Python execution lab 5, then we're importing OML again, and then we're going to be loading scikit-learn, right? So we're going to use data sets from scikit-learn and a linear model as well. And then here, what I'm doing here is I'm just creating a data frame. This is a Pandas DataFrame, right? So it's not yet the OML, right? That OML table. The OML table is the big one with capitals, right? The iris one. So now what we're doing here is we're going to build and score a linear model, right? In scikit-learn. So for scikit-learn, I need a plain Pandas DataFrame, right? Scikit-learn does not know what to do with it with a proxy object from OML. So scikit-learn is going to say, okay, give me the X and the Y that are my normal Pandas data frames. So this is where we're doing. We're giving it an X, giving it a Y, and printing the output. It's a linear regression. Great. So we're just testing that this code works, right? That's basically what we're doing. So, and then now that I created that model, right, I can predict with it. So I'm going to, if I give you a petal width, will you give me the petal length, right, estimated? And you get the output, right? So again, I'm still in Pandas DataFrame standard Python, right? So now I'm gonna check, the mean square error of that. So give me the coefficients and R squared, right? The variance here. So it shows me, the R square, 0.93, mean square error 0.23. Okay, and I get a plot. So I'm gonna again still using, open source Python, right? So I get Seaborn, I get the output, and this is basically what I get, right? So now I'm going to build that using embedded Python execution, right? So I start by defining a function, right? So this is the function. I'm going to test if it works. So I'm going to build the function, and then the input is going to be the data, and that's what I'm going to do. So let's test it. So build LM1. So I get back the chart and the model, right? I'm getting 2 objects back out of that function, right? Because remember, we're building the model, we're doing the fit, and then I'm returning the model here. So I'm showing the plot and returning the model, right? So I got those 2 back. So let's use table apply. So for table apply, I need to make some changes. Instead of build LM1 being the function like I had before, like this one, I actually have to create a triple double quotes text, right? Long text here, which is going to be my script. Okay, so that's my script. So now I'm going to use table apply, and now see that I'm passing the OML proxy object, right? I'm passing the big iris here. I'm calling out that function, which is build LM1, okay, and then graphics equals true. So that's my output here, right? And then there you go. So I'm saying, okay, now let's define that. So I need to import matplotlib, right, to get my image back. And then from image data, so I got to define that function so I can plot that output, right? So I'm plotting that image output, and there you go. So I can see the output of that image, shown into my session, right? So basically, remember that the output has other things in it, right? Not only the chart. So the output had the model. So what I'm going to do here is I'm going to get the model and I'm going to list the model coefficients as well, right? Because that's the model object, right? So when I get the model, I say .dat, I'm saying give me the data components out of that object. So this is basically what the model shows me, okay? So we have other functions like row apply, which actually, instead of parallelizing it by groups or indexes, is going to run a parallel threads by row. Very useful when you're doing scoring, right? When you're scoring your customer base, you can say normally that these are independent things happening, right? The first 10 records or first 10 customers are different than the second set of 10, 10 customers. So these things are independent of each other, every row. So row apply allows you to do that. So you take all of those parallel functions and you say, how many rows would I like to use in parallel? Okay, when you're doing row apply, the default parallelism, I think it's 2, if I'm not mistaken. But you can also tell it, how many parallel threads you would like. The database has limits, right? And the DBA is going to put you limits on your autonomous database as well. So of how many parallel threads you can have. So it's not like, oh yeah, I'm going to have fun and put 256 here parallel. But it's going to do as much as possible, as much as you are allowed to, right? So that's the idea here. And then one model per species, group apply. So you're, again, building the same kind of functions, but now group apply. And then remember that we needed that index to run, so that I'm splitting that in the different indexes, and then I'm running them. So the output now comes back as, I have one linear regression for Virginica, one type of flower, another linear regression for another type of flower, and another linear regression for the third type of flower. Okay. So anyway, we have many more tests that you guys can do. We can also call the same function several times and return multiple images from an embedded Python execution. So these are all more details, right? So you can return, multiple graphs, right, coming out of that random red dots, and passing parameters. So to how many dots what I like. So I'm passing specific parameters to the functions. Okay. And finally, I'm going to lab number 6. So notebooks. And we're going to go lab number 6, use AutoML. So the AutoML basically is going to help you build and work with the functions in a smarter way, right? It's going to work with the machine learning algorithm. So let me show you a quick intro on it in my sets of slides, because it's going to be it's going to make life easier here. Okay, so the idea here is to help the machine learning and the data scientist make things faster. Some repetitive tasks, right, make them easier. So we're going to apply machine learning to the machine learning process itself, right? So what we do is we're going to go through these steps, which are an algorithm selection. So the first thing is, out of all the algorithms we have available, which ones are the best ones to try to classify, your customers that are about to churn, or the customers that I need to give credit to, right? So what's the best way to identify good and bad customers? That's the first step. Second step is, okay, now I'm going to do feature selection. So I'm going to go and look at all the features, all the attributes, all the columns, right? And I'm going to say, for this type of algorithm, these are the best features that are helping the algorithm determine the best model. So that's the second step. And then the final step is, okay, let's tune that model. So looking at the decision tree, how many splits should we have, right? How many records per split? Looking at the neural networks, how many layers of neural networks do we need here, right? How many neurons in each? So the fine tuning at that point. So the great thing is, it makes life easier for us, right? So that's at that point that's the simplest thing for us. So when you're on AutoML here, first step, we're going to import OML. There is a special one, so you actually need to tell it to import AutoML. Okay. So we need to purposely tell it, okay, I need AutoML out of that OML component, okay, because otherwise you get an error. So we're going to use our friend, the customer insurance lifetime value from that OML user schema. We have 13,880 records, 31 columns. These are the columns, right, that we saw before. So we're going to do automated algorithm selection, right? So the first step is split X and Y. As the Y, I'm going to get by insurance. So that's my target. I want to identify which customers are going to buy insurance, and I'm going to drop by insurance from my inputs, right? And that's basically it. I'm going to say algorithm selection. This is my mining function, a classification. This is the score metric. You have many score metrics you can check on the help files. Accuracy, balance accuracy, F1, recall, right? So there's a lot. And then parallel equals 2. That means, I know I have very little parallel capability on a free tier, but I still do have, I could potentially ask for 2 here, okay? If you are using on your own environment, you will have more, right? So it's not going to fail if you don't have available parallelism. It's not going to fail on you, okay? But insurance algorithm ranking. So here is when I'm going to do the select. So that the algorithm selection is going to happen. I'm telling it, give me the top 4 algorithms, right? That's the k equals 4 here, okay? And this is the case ID I'm using. This is a list of the top ranked algorithms. So when it builds, this is what it shows. It shows me the top ranked algorithms here. Random forest was the best one for this one, and this is the accuracy. Decision tree is the second one. Neural networks is the third. GLM is the fourth. Okay. So that's what the algorithm selection is doing. So what I'm doing with this line here is I'm just keeping this string called RF. Okay. That's a string that I'm keeping in memory for the next step. Okay. So I'm not keeping any of those models. I'm just keeping the fact that the random forest is the best. Now for feature selection. So now I'm going to pass into the feature selection process, right? Same thing. I'm going to pass the selected algorithm. So I'm going to say, take the best algorithm from before and put it here. That's just going to be RF. That's the string, okay? And X and Y, and then you got a case ID, okay? Again, we're going to get the features. We're going to append customer ID just because the features, when they are being selected, customer ID is going to be left out. But we want to make sure that we add that in, right, back into the list so that we can continue to the next step with the customer ID, right? That's going to be critical for us because we need that customer ID to be part of the data set, of any of these processes going forward, right? So we keep customer ID here, and then we're going to remember the selection of columns. So we're going to select only the columns that were determined to be important for random forest, right, by this process. So that's what we're showing here. So we're showing number of columns. Originally, there were 30, and they were reduced to 23, okay? That's what the process did. So from the original customer X columns, we now have a customer X reduced, which we created, which only contains the actual important columns, okay? And then finally, the model tuning. So now I'm going to tune the model. What I'm telling it is now take the selected algorithm, take the selected attributes, right, the 23 selected attributes, and now go look at my target, and this is a customer ID, and go tune it, okay? So it's going to run that process, and it's going to say, okay, let me check on that algorithm, and it's going to be tuning the algorithm, and this is the final algorithm, okay, the best model, all right? So now finally, this is the best model. These are the best settings that it could find, okay? Depending on the algorithm you look at, it's going to tell you, okay, what are the type of trees, number of trees that it found, the sampling ratios, right? The tree impurity metric, all of these things were determined by the AutoML process to be the best ones for these guys. So now I have basically that model, right? And I can list the hyperparameters that were tried or tested by the model. So I can take something called the all evaluations, right? All evals out of that tuning, and I can say, show me the top, 3, right? From 0 to 2. So show me the top 3, or the top 2 here. So show me the top 2 ones, right? And that's what I can see here. I see that this guy is 1, and this is the second one, right? This is another one that was tried in the order that were, the best ones. And if you scroll down, you can show you an easier way to see the top 10. So these are the top 10 tests, right, that were run, and this is the accuracy, right, listed by accuracy. So these are the settings that were tested by the models. And if you keep scrolling down, you can see there the accuracy reduced, right? And I can see other accuracies, and these are all the settings that were tried as well. Okay. So you can specify a range of things. So, another option is I can specify a search space, and I can say, Marcos, I would like to check the sampling ratio myself between 5% and 50%. I would like for the number of trees to be tried between 50 and 55, right? I would like to try the 2 different impurity metrics here, entropy and Gini. So you can establish your own search space if you know what you're doing, and then you can let it search through that. So it can give you back the result. So the result model here has an F1 macro of that, and these were the best parameters, right? These were the parameters that it came back with. Okay. So finally, we actually have one guy that does them all. So if you take a look at model selection by itself is going to do part of that, right? It's going to actually do algorithm selection. It's going to do algorithm tuning. So by itself, it's going to do the process. So the result of this is just one model. Instead of being the name of the technique like we had before, the model selection is actually selecting a model for you immediately. So it looks to all the different processes that it can, and it comes back with the top model for you. Okay. In this case was a random forest, and it gives you that process. Now you can take a look at down here how long it takes, right? These are not lightning fast processes. AutoML always takes time. This guy took 3 minutes, 25 seconds, for example, right? Back when we ran them. So these are all processes that take time because they're doing and testing several machine learning algorithms behind the scenes. Okay. All right, guys. So I think we are almost 20 minutes over. So I would like to thank you guys for your patience. And then, well, that's it. Basically, really appreciate you guys staying through the process. I will link, we're going to link a PDF where you guys can see the bonus steps so that you guys are going to be able to follow it, right? If you want to follow the step-by-step AutoML portion, okay? So you guys don't feel left out. And then you can see how to do the AutoML UI, right, by yourself. So it's just clicking around. So I have all the instructions in all the slides. We don't have those instructions yet in the course itself. They are all in the slides, okay? So I'm going to show you, I'm basically going to share with you guys that those slides, all right? So far, so good. Hopefully you guys are okay. Questions, Mark? Any more?
No, I think we're all covered on the question front. And so thanks, Marcos, for a great workshop. This is really, really exciting.
All right, guys. I really appreciate it. And then, well, looking forward to seeing you guys next time on the Oracle Machine Learning Office Hours.